In this video, I would like to make connection between the binomial distribution we learned in the past and the normal approximation for the proportion. So in this question, when we sample, let me see, 100 residents in Ventura County, about 40% of them have earthquake supplies. Now, based on this, when I sample a person, they will either say yes or no. So we have discrete random variable, and that tells me that I have binomial distribution, and the parameter is 100 and 0.4. So make sure you convert the percentage to decimal. Now, based on this, I would like to calculate the probability of x that is in between 50 and 55. We learned that in module number 5. This is equivalent to probability of x less than or equal to 55 minus anything that comes before 50. So that is probability of x less than or equal to 49. And with this, we use binom CDF and 100. That's why I had you wrote down the parameters minus binom CDF 100.4 and 49. You could plug that into your calculator and verify the answer in, actually wanted to show it to 4 decimal places if necessary, is 0.0262. Now the second part of question asks us to find the distribution of p hat. Let's scroll up and see what is p hat. P hat is the sample proportion. And recall that sample proportion, let me use a different color. Sample proportion equals the number of success divided by the sample size. So this is how we calculate proportion. And we learned that previously the distribution of sample proportion is approximately normal, provided that the proportion we have, that is 0.4, is not too extreme. In this case, we have 0.4. Of course, it's not too extreme. And the parameter, the mean and the standard deviation, is p and square root of p times 1 minus p over n. And in this case, this p is 0.4. Remember, this n is 100. Plug in all of the numbers. Let me see what I had. Oh, I had 0.0490. That is the standard deviation of my sample proportion. Now I want to repeat that calculation and find the probability. X is between 50 and 55, but we are going to use the distribution of p hat to make that approximation, which means I want to know what is the probability of p hat that is between, remember, p hat, the proportion, equals x over n. In this case, that would be 50 over n, that is 100, and 55 over 100. Once again, that n is the sample size. If your sample size is 200, put down 200. It's 250, put down 250. So it's not necessarily 100. It just happened to be 100 in this case. So for here, we will use normal CDF. The lower bound is 0.5. The upper bound is 0.55. Notice that difference between this calculation and the previous calculation. And then the mean is 0.4 and the standard deviation, I'm out of space to write. Let me see if I could squeeze. I just dropped my 0. Okay, let me just rewrite that 0, 4, 9. Okay, when I plot that into my calculator, I see that the normal approximation for the sample distribution is give us 0.0195. So if you compare my approximation, it doesn't allow me to change anything anymore. If you compare my approximation with the exact answer, 0.0262, it's a good approximation. It's not a perfect approximation. And notice the calculation, and it takes about the same amount of time to go through the calculation for the exact binomial distribution or the normal approximation. Then why from now on we want to go through the trouble and learn the normal approximation? Because in the future, if we want to estimate the sample size, the number of people we have to sample, or we want to extend that from one proportion to two proportion, we will need the normal approximation. And here I provide you the theoretical background. Okay, so this is the end of my recording. If you have any questions, please do not hesitate to contact me, and I will happy to follow up with